All right, so our second lesson in review for chapter 4 is dealing with rates. Now, rates are very similar to ratios. So as long as you pay attention to the last video and you pay attention to this video, you'll do just fine. Once again, should be pretty easy on what we're doing. But I have to do a lot of reading at times on some of these questions to figure out what exactly is being talked about. It says Kevin's cookie recipe uses a ratio of 4 parts flour to 2 parts sugar. Anna's recipe uses 5 parts flour to 3 parts sugar. Could their recipes make the same cookies? Well, we know that these are our thinking patterns that our book gives us, and it helps us guide our thoughts as to what we're supposed to be looking for. What do you need to find? I need to find out if the ratio blank to blank in Kevin's recipe is equivalent to the ratio in blank. So we're talking about flour to sugar, right? So I have to find out if the flour to sugar ratio is the same between Kevin's compared to what? Well, we're only comparing it to Anna's recipe. Well, what information do I need to use? Well, I will use the blank of blank to blank. Well, that's really confusing as to what they want you to figure out. Well, I'm going to use the ratios of flour to sugar is what it's actually asking. You could have said the ratios in Kevin's to Anna's, but they're looking for, well, I'm just going to look at the ratios of flour to sugar in both of them that are set up. How I use that information? I will make blank to compare the blank. Well, what we talked about in the previous video was finding if things were equivalent or not. Well, if I make them equivalent, then I would be able to prove that they're correct. And on your paper, I left these tables that it's talking about. Well, these tables tell me what the equivalent ratios are for that particular ratio, and then I see if I find one that matches. So I'm going to use the tables to compare the ratios that we're talking about or the rates that we're given. Make the equivalent tables. So they've already been made for you, and I left them on your paper for you. So you can see these are Kevin's recipes, Anna's recipes, and how they increase. These are increasing by 2, 3, 4, 5. Same thing down at the bottom. So then I'm going to find an amount of flour that is in both tables. So when I look at the amount of flour, I have a 4 here. Do I have a 4 down here? I don't. I have an 8. Do I have an 8 down here? No. And I keep going until I see that my 20s have the same amount. It's the only one in the flour that does have the same amount. So if they are equivalent, then that means if the numerator is 20 and they're equal, then my denominators would have to be equal as well. Well, when I look at Kevin's recipe, I have 20 to 10. And when I look at Anna's recipe, I have 20 to 12. So they're not the same. Okay? So their recipes could not make the same cookies. So it's just the thinking process that we need to be going through and asking ourselves as we answer different rate and ratio questions. For example, I have 2 here. Sharona takes a 6-minute break after every 24 minutes of study. Benedict takes an 8-minute break after every 32 minutes of study. Are their ratios of study time to break time equivalent? So my ratios that I'm looking at is a comparison of 6 to 24. Then I want to know if it's equivalent to a comparison of 8 to 32. So when I set them up, I'm going to take my 24 minutes. I know I'm going to study for 24 minutes and then break for 6 minutes. When I talk about Benedict, then I'm going to study for 32 minutes and I'm going to compare that to an 8-minute break. Are these equivalent one to another? So what I did on the last video is I talked about the butterfly or the cross multiplication. So if I multiply across and then I multiply across, it makes that butterfly multiplication sign, then the product should be equal if they are equivalent one to another. So let's try. When I multiply 6 and 32, I get, on my handy-dandy calculator, 192. When I multiply 8 and 24, that makes that butterfly, that multiplication sign. 8 times 24 is also 192. So will they spend the same amount of time studying and the same amount of time breaking? Yes, they absolutely will. What about Micah and Rachel then? So in the second one, it says Micah buys 10 pencils for every 2 pencils. Rachel buys 12 pens All right, that should be 10 pins, excuse me. Buys 12 pens for every 3 pencils. Are there ratios of pens to pencils bought equivalent one to another? So I set them up again. I put 10 over 2, and I put 12 over 3. I'm going to multiply the loops and compare them. So the loops make 2 times 12, which is 24. 3 times 10, which is 30, and no, those are not equivalent. So the answer is just simply no. These are just yes and no because that's what it's asking. Are they equivalent or are they not equivalent? Yes on the first one, no on the second one. Well, what is it asking me to do here? Well, if I read it, I know Chase is making some kind of snack thing and a snack bar, and I have to figure out some information on what's going on. So it says Chase is preparing for a weekend group hike. Some parts of his recipes are missing. Make tables of equivalent ratios and then complete the recipe. So on your assignment, it may say that you have to fill this out first because it's missing. So we do that before I could even answer what these are. So I start with the recipe for the snack, and then I have a recipe for a drink. Chase is making energy bars that contain sunflower seeds, rolled oats, and dried fruit. The ratio of sunflower seeds to rolled oats is 1 to 2. The ratio of sunflower seeds to dried fruit is 2 to 3. So when I start with my sunflower seeds, then I compare it to my rolled oats, it tells me it's in a ratio of 1 to 2. When I have my sunflower seeds compared to dried fruit, it tells me it's in a ratio of 2 to 3. So I have to fill in my chart first. So I go and I just do my basic multiplication facts. I'm going to multiply by 2s, I'm going to multiply by 3s, I'm going to multiply by 4s. Why would I do that? Well, when I look back at what we're talking about, I know that I'm going to have 4 cups of sunflower seeds. That's how I know that I'm going to get enough. Because if I go out 2, 3, 4, that gets me to the 4 that I need. So that's pretty easy because I'm multiplying each of those numbers by 1, and that gives me the number. But here I'm just multiplying by my 2s. So I have to do my counting by 2s, 2 times 2 times 3 times 4, and I can fill in my chart. So I know across the top I'm going to have 1, 2, 3, 4, but at the bottom then I have multiplying by 2s. Times 2 is 4, times 3 is 6, times 4 is 8. When I look at my sunflower seeds then, I'm still going to have this 4 cups they tell me of sunflower seeds. So if I multiply by my 4s, 1, 2, 3, 4s again, it's going to get me my number that I need down here. So I know up here though, I'm multiplying by 2s, and 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. Then at the bottom, I'm multiplying by 3, so I just do my basic multiplication facts of 3s. 3 times 2 is 6. So I have 2 times 3 is 6, 3 times 3 is 9. 2 times 4 is 8, and 3 times 4 is 12. So I have my chart filled in. Now I have to look at the 4 that it's talking about. If I have 4 cups of sunflower seeds, how many cups of rolled oats do I have? So if I have 4 of the sunflower seeds, then on my rolled oats, I have 8. So I'd have to put an 8 there. And then when I talk about the sunflower seeds to my dried fruit, once again, I'm having 4 cups, because that's what it tells me. So I know that my matching number has to be a 6. So I have to have 8 cups of rolled oats, 6 cups of dried fruit. That would give me my overall mixture that I'm looking for. The next one's a little bit more complicated than that. Number 1, they throw a decimal in there. But number 2, if I just multiply by 1, 2, 3, 4, I'm not going to be able to get to the answer that I need. So let's look at what we're talking about. How about this weird, funky energy drink that I would never drink because it sounds nasty? However, says he's making this energy drink that contains water, lemonade, and protein powder. Gross. The ratio of water to lemonade is 2 to 2.5, or 2.5. The ratio of water to protein powder is 8 to 1. What that's saying is for every 2 cups of water, I'm going to have 2.5 cups of lemonade. And for every 8 cups of water, I'm going to put 1 cup of protein powder. So if I would just multiply by my 4s, is it going to get me to the cups of water that I need? Well, I need 16 cups of water. If I just multiply 1, 2, 3, 4, it's not going to get me there. So I have to do some mixing around until I know I get to how many cups I need. So what I did is I multiplied by 4, by 6, by 8. By 8 times 2 will give me the 16 that I need. Therefore, I have to multiply my bottom and top by 8 when I get there. So when I do my 4s, I get 2 times 4 is 8. 2.5 or 2.5 times 4 is 10. When I multiply by 6s, I get 12 to 15. So then when I get to where I need, I multiply by my 8s. I have 2 times 8 is 16, and 2.5 times 8 is going to be 20. When I go to the bottom then, I'm going to look at what I need, which is 16 cups. If I multiply by the 2, 3, 4 like I did before with the snack, then I still get to my 16. So I don't have to figure out a different measurement to go by. If I just multiply by my 2s, I know I've gotten to the point that I needed to get to, but I went ahead and filled it out for all of the boxes in that particular chart. So when I look at it, have 16 cups of water, then my 16 cups of water tells me that I'm looking at how many cups of lemonade. Well, I would need 20 cups of lemonade. And if I have 16 cups of water, I go to my 16. How many cups of protein powder do I need? Well, I would need 2. So my rest of my chart information would be 20 and 2. So it's just using the rates that we're given to come up with the proper answers. Now, finding the rate is just by stacking them as a ratio, reducing if I can, if it tells me that I have to. But I also have to have labels. So we've talked about rates multiple times, like miles per hour and things like that. We'll get into unit rates in the next video. But on this one, it's simple, it's easy, as long as I just remember to put labels in the correct numbers. So if I have 9 pencils for $10, then I write it as a rate. I put 9 pencils over $10. If I have 9 chocolate bars that cost $13, then I'm just going to put my 9 bars over $13. Not difficult, right? It's not meant to be difficult because we would then take these and know which way to put them in a math problem. I just have to know what I'm doing. $7 for 4 cans tells me I have $7 to 4 cans. 100 miles on 5 gallons of gas tells me that I have 100 miles per 5 gallons. 8 batteries cost $25. So I'd have 8 batteries to $25. Should not be difficult at all. Should be pretty easy. You should be able to get this done rather quickly. About a 13-minute video should be an easy A for everyone for our grades to go up as we quickly are approaching the end of the year and you're almost 7th graders.